Hello everyone, welcome to Royal Palace online classes. So let us continue our discussion on electromagnetic waves. So in the last video, we discussed the history of electromagnetic waves, how Maxwell proved that Ampere circuit law is wrong. So here, yesterday we discussed the experiment what Maxwell has done between the two parallel plates of a capacitor. He applied a potential difference and he observed 2 points P and Q because of the current flowing in the wire. There is a magnetic field around this wire like this. Similarly, when he kept a compass needle between the plates of the capacitor, the compass needle started to deflect. That means there exists a current between these plates also. There exists a current. So he has proved that time variation of electric field. Once you create positive and negative charges to the plates of the capacitor, there exists an electric field. Inside the capacitor. That electric field is given by sigma by epsilon naught. This you will get in the derivation of the capacitance of the capacitor. When you are deriving the capacitance of the capacitor, you will get this. E is equal to Q by epsilon naught A, because epsilon this sigma is Q by A. So E is proportional to Q. So what happens here, at each and every point at time t is equal to 0, charge on the capacitor was 0. As the time increases, this battery will take one electron from this side, from positive plate of the capacitor, and send it to the negative plate. It will take one electron from here, that will move like this, and the movement of electron opposite is the direction of current, and this current afterwards he will name it as conduction current. Let us see how we will name it. Now there is a variation of electric field. E is proportional to Q. Q is changing with respect to time. Current is induced due to the change in electric field. The change in electric field has produced magnetic field. Change in electric field, change in E produces B. So in previous case what you have studied, change in B produces E, that is in electromagnetic induction. So he proved that it is possible the time variation of electric field produces magnetic field, but the people did not accept. So according to the people at that olden days, according to them current only should produce magnetic field. So when he said that Ampere circuit law is wrong, because here there is no current, but still we are getting magnetic field. So when he said that Ampere circuit law is wrong, people did not accept it. They said that current only should produce a magnetic field. You are producing a magnetic field in between the plates of the capacitor, and that magnetic field having the same strength B inside, that is B at Q. B at Q is equal to B at P, because same deflection it is showing. Without having current, we can't get magnetic field. So in order to explain them, he introduced the idea of displacement current, introduced a new term called displacement current. So what is displacement current is the current which is produced due to change in E, due to change in electric field. The current which is produced due to change in electric field is called displacement current. displacement current. This is the meaning of displacement current. Displacement current is not a conventional current. It is a current which is assumed to be produced due to change in electric field. If there is no change in electric field, there is no displacement current. There is no displacement current. And if you observe this electric field will be restricted within the plates of the capacitor. If you take the area of the capacitors as A, later on he found that displacement current is proportional to, displacement current ID is proportional to electric flux. Electric flux, that means change in electric flux. Change in electric flux by time taken. Change in electric flux by time taken is responsible for displacement current. If you remove proportionality by using dimensional formula, he written that it is equal to epsilon naught dE by dt. The rate of change of electric flux produces displacement current. The rate of change of magnetic flux has produced conventional current, that is conduction current. So this current he named it as conduction current, this current he named it as displacement current. So in order just to explain, he introduced a new term called displacement current, which is produced between the plates of the capacitor. Formula for this is epsilon naught d phi by dt. So when you changing electric flux, the current has been induced, current has been formed inside the capacitor. This current we call it as displacement current. So it depends upon rate of change of electric flux. When you remove proportionality, he has written epsilon naught. This epsilon naught he got from dimensional analysis. By using the dimensional formula, we defined it. It is epsilon naught times the rate of change of electric flux. So that is what is called displacement current. And if you observe here, it also solved a biggest question in electrostatics. What was that question is, if you take any circuit, current follows the complete circuit. Current should move in a complete circle. It should follow the continuous pattern of current. Suppose you take, there is a capacitor which is connected to a potential difference V. Now if you observe, this is current I. So if you complete the loop, current will stop here. Here there is no current. According to our definition, capacitor blocks direct current. So capacitor is blocking this current. So this continuation of the current is stopped within the circuit. So where that current is going here, how it has become zero? How it has become zero? Current I is flowing through the circuit, but at this point we will tell that current is zero. So current disappears here, again it reappears here. How it is possible? It is not possible. So for that reason, displacement current explains the continuation of current in a circuit. So in a circuit, current, here it will be conduction current, here it will be displacement current. Here it is conduction current, here it is the displacement current. And conduction current is equal to displacement current. Why conduction current is equal to displacement current? We can prove it. Formula for displacement current is epsilon naught d phi by dt. Okay, this is epsilon naught E into A if you take cos theta as 0, E into A by dt. Okay. Now electric field within the plates of the capacitor, what is electric field? Sigma by epsilon naught d q by A epsilon naught by dt. Okay. From this I am writing sigma by epsilon naught q by epsilon naught A. Now here the only thing which is varying is charge, dq by dt into dq by dt, here A is there, this A and A will get cancelled, epsilon will get cancelled, you will get this as dq by dt, this is displacement current. Then what may be the formula of conduction current? Conduction current is due to change in the charge, so conduction current is also equal to dq by dt. This is the definition of current, rate of flow of charge. So charge is changing with respect to time, dq by dt, so both are same. So displacement current is equal to conduction current. So conduction current disappears here, it appears as displacement current, and this current loop is totally continuous. The flow of current is continuous, it is not blocked. Capacitor blocks the current, but inside the capacitor it flows like displacement current. It flows like displacement current. The current which is produced due to change in the electric flux is called as displacement current. And if you see the properties of displacement current is not a conventional current. It is produced due to the change in the electric flux or electric field. Next point what you can remember is, displacement current will not be formed in steady conditions. Whenever there is a change, at that time only displacement current is possible. And next, displacement current allows the continuous flow, explains the continuous flow of current inside a circuit. So inside a circuit, the continuous flow of current is explained by displacement current. So current disappears here, reappears here, this is not correct. So inside a capacitor it flows like an displacement current. So this is what he explained about displacement current. So displacement current formula, how much you got? It is id is equal to epsilon naught d phi e by dt. So one more formula you can derive for displacement current. The formula for one more formula for displacement current is displacement current is equal to epsilon naught d phi e by dt. Okay, this you can write epsilon naught d of, this is E into A by dt. Okay, this E, negative gradient of potential is filled. So what I can write, E is equal to dV by dl, dV by dl, or dV by dl you can write. So this I can write epsilon naught d dV by dl into A by dt. Now this A and dl you can take outside, directly you can write V by dl, E is equal to V by d you write. For simple understanding you write E is equal to V by d, here also you write V by d into A. Now this A and d are constant, you can write this epsilon naught A by d, epsilon naught A by d, dV by dt, dV by dt. Now epsilon naught A by d, can you remember, it is the formula of one physical constant, that is nothing but capacitance. So this you can write it as C dV by dt. This is another formula for displacement current. This is another formula for displacement current, and displacement current exists as long as there is change in the electric field, and displacement current produces magnetic field inside the plates of the, between the plates of the capacitor. And now after proving this, he has changed the Maxwell law, he has changed the Ampere's law, Maxwell has corrected the Ampere's law. What he says is Ampere's law is completely wrong. It has proved successfully. He has proved it successfully. He has proved that Ampere's law is wrong. What is Ampere's law? You already studied in moving charges and magnetism. Ampere's law is equal to, what is Ampere's law? That is integral of B bar dot dl, integral of B bar dot dl is equal to mu naught I. This is what Ampere has given. But what Maxwell will say, what Maxwell has corrected this. Maxwell has corrected this. According to Maxwell, it is B bar dot dl, B bar dot dl bar is equal to mu naught into IC plus ID, whether it is equal to this or not. So the thing is, wherever there is conduction current, displacement current will be 0. Suppose if I am applying at this point, let us take at P, I am applying the Maxwell and Ampere's law, Ampere Maxwell law. This is Ampere Maxwell law. Maxwell has corrected this. This is nothing but Ampere Maxwell law. Ampere Maxwell law. Ampere Maxwell law. So if I apply Ampere Maxwell law at P only conduction current is there, displacement current is 0. And at D, if I apply at Q, in between the plates of the capacitor, if I apply this law, here there is no conduction current. Capacitor can't conduct the current, capacitor blocks the direct current. So here ID is present, IC is 0. So therefore at P, let us take the 2 points. At P, B bar dot dl, integral of B bar dot dl bar is equal to mu naught IC, mu naught IC. At Q, that is in between the plates of the capacitor, it is integral of B bar dot dl bar is equal to mu naught ID. But we already know that IC is equal to ID, therefore it is equivalent to mu naught I. It is just a correction. He is not telling that Ampere's law is totally wrong. There is some correction because it has some exceptions. Even though when we are doing the video of Ampere's circuital law, I given 3 limitations which that NCERT has given. If you see your NCERT textbook, there are some 3 limitations to apply Ampere's law. Ampere's law can be applied only under 3 conditions he has given. So there also we mentioned some conditions. So because of that conditions, Ampere's law is having some inconsistency. If you observe your textbook, he has used this word inconsistency of Ampere's law is found out by first time identified by Maxwell in 1831. So this inconsistency of Ampere's law has proved that time variation of electric field produces magnetic field, and according to the scientists, magnetic field must be produced by a current. So that current Maxwell called it as displacement current. The time variation of magnetic field produces electric field, that is already given by person called Faraday. So Faraday already shown in his laws about the time variation of magnetic field will produce electric field. If you change magnetic flux, you will get electric field. If you change electric flux, you are getting magnetic field. So this is all about displacement current, and this is the correction made by the Maxwell. So now Ampere's law is this. This is Ampere's law now. This is Ampere's law. And Maxwell has given another 4 equations in this electromagnetic waves that we will discuss in the next class. So thank you everyone for joining me.